Morning, guys. Here's our big read for this week. We're in our literature anthology. It's the one with the guy in the helicopter. We're on page 48. Recall that our genre this week is expository text. Expository text is facts, facts, facts. Lots and lots of facts. They also have some kind of illustrations, headings, as well as graphic organizers. The title of our story is Earthquakes. We like to believe that the ground under our feet is solid and secure. People who have felt the ground shake know differently. They have lived through an earthquake. Earth's crust resembles a jigsaw puzzle more than a solid sphere. Like a puzzle, the crust is divided into different pieces that fit together. These pieces are called plates. Earth plates float on top of a layer just above the crust called the upper mantle. The upper mantle is solid rock, but it behaves like a thick gel. Heat from deep inside the earth moves through the rock and causes it to slowly swirl and flow. The residents of this town inspect a large crack on the road after an earthquake struck the area. So these plates push past each other and then cause this big crack in the road. Look at this. Looks like it raised up here where the car is. Dr. Ines Cethesis is a seismologist, someone who studies earthquakes. She likes to compare the movement of earth plates to boiling milk. When you boil milk, she says, you get a little surface layer of cream on the top that moves and dances around. That's what's going on the earth, except that the earth's crust is much harder than the layer of cream. As the mantle boils, it pushes and pulls the plates above it. It's at the edge of these plates, Dr. C explains, where we have most earthquakes. Now, if you're familiar with this map, this is a map of the world. Right here is the United States of America, and you can see where one of these plates is just on our west coast. A lot of our big earthquakes happen on the west coast by California. Earth's largest quake, a first-hand account, is the title of this section. Dr. C became a seismologist after a very good reason. She and her family lived through the largest recorded earthquake in history. This was the 1960 earthquake that struck Chile. As Dr. C explains, in April 1960, my family moved to Santiago, Chile. Just a few weeks later, on May 21st, we were woken up by strong shaking. Then, 33 hours later, a gigantic earthquake hit the southern part of Chile, and with it, an enormous tsunami. About a year later, we took a trip to the northern end of the earthquake zone, and that's where I saw that the land had actually been raised up a meter or so. A meter's like 3 feet. So about half as tall as I am, and about probably up to your waist or shoulders. I saw these huge changes, and that impressed me, that the earth could actually do that. Later, as a graduate student, I wanted to know how big that earthquake was, how long it lasted, and what it was preceded by, a slow earthquake. I worked on this problem for 4 years. I was able to calculate the Earth's largest recorded earthquake had a magnitude of 9.5. I also confirmed that a slow precursor, or forerunner, that means something that comes before it, had occurred 15 minutes before the main earthquake. I am very proud of this work. Page 52. Whose fault is it? Now, it's kind of a funny play on words there, because where these two pieces of earth come together, that's called a fault line, and that's where these earthquakes stem from. Earth plates crash together, spread apart, and slide against each other. Wherever they do this, they cause breaks on Earth's crust. Seismologists call these breaks faults. Usually, the blocks of rock on Earth on each side of the fault just sit there stuck together. But when enough pressure builds, the two sides of the fault can suddenly shift or slip. This sudden movement releases waves of energy. These waves travel through the earth. We feel them as an earthquake. Most faults do not slip or cause earthquakes. Around the globe, however, active faults can cause hundreds of earthquakes every day. Most are too small for us to notice. Once in a while, Earth unleashes a whopper. So here's the diagram. The diagram below shows a normal fault, which is a crack or a fracture in the Earth's surface. Movement along the fault can sometimes cause earthquakes. So when they shift past each other, then that down there is where the earthquake happens, and it sends out these waves of energy, making the earth move. Measuring earthquake. Seismologists record earthquakes using machines called seismographs. These measure shaking or ground motion. After an earthquake, scientists read their seismograph. They use their reading to calculate the earthquake size or magnitude. Magnitude scales are set up so that each number is 10 times larger than the number before it. A magnitude of 7.0 earthquake, for instance, is 10 times larger than a magnitude of 6.0 earthquake. Truly giant earthquakes happen about once a year. These are quakes with a magnitude of 8.0 or greater. They occur only on very large faults and can cause severe destruction. So there's our severe destruction again that we've been talking about this week. Dr. C explains, the only way you can get an earthquake like the 2011 Japan earthquake is where one of the earth plates is sliding under another one. This is the only kind of place where you can have a fault long enough and wide enough to release that kind of energy. Seismologists gave the 2011 Japan earthquake a 9.0 magnitude. It was the fourth largest earthquake ever recorded. They believe that the earthquake occurred on a fault more than 150 miles long. It shook Japan for 3 to 5 minutes. It was so powerful that it altered the geography of the country. Surprisingly, it wasn't the shaking of the ground that did the most damage. A massive wave proved much more dangerous. We have a novel that we'll read called The Big Wave, and we'll learn more about tsunamis in that book. So this is that little machine, and it measures the earth movement with this little pen. And when the earth moves, then the pen moves faster, and then they can read that to see how much shaking there is of the earth. This is how big that one was in Japan. So look, if you look at your picture, that's a human being. So imagine how big that boat is, and they picked that boat up and they put it up on shore. That wave did that, smashed all these boats in that one little area. When an earthquake occurred under the ocean, it often moves a substantial amount of water above it. This creates a fast-moving wave called a tsunami. Out at sea, the wave may be only a few feet high. As it reaches shore, however, the wave can tower into a monster. It can hurl water for miles inland. Tsunamis can travel thousands of miles. In 1960, Earth's largest recorded earthquake struck the country of Chile. It produced a tsunami wave up to 82 feet high along the coast. The tsunami also raced across the Pacific at the speed of more than 150 miles per hour. It struck the shorelines of Hawaii and Japan, Alaska, and other places. Hundreds of people drowned. The 2011 Japan earthquake produced tsunami waves more than 30 feet high. The 2004 Indian Ocean earthquake in southern Asia produced a 50-foot tsunami. These tsunamis engulfed entire cities and shorelines. The waves swept away buildings, cars, and people. Japan, South Asia, and Chile have experienced more powerful earthquake tsunamis before. Why were so many people unprepared? Predicting earthquakes. Seismologists are very good at measuring earthquakes. However, they still can't predict when earthquakes will happen. There was a time, Dr. C explains, when I think scientists felt that predicting earthquake was just around the corner. Now, that's an idiom there, guys. We're still studying idioms this week, and just around the corner means we almost got it. We're almost there. That we were going to be able to predict earthquakes very soon. But it's clear now that it's not around the corner. In fact, some have given up entirely on predicting earthquakes. One reason that earthquakes are unpredictable is that scientists cannot collect enough information to understand where and when an earthquake might happen next. Although scientists have placed special instruments in many earthquake zones, earthquakes still surprise us. Scientists, for example, had believed the next big earthquake in Japan would happen farther to the south, closer to Tokyo. Instead, it struck farther north. Look at this. Whole airport's underwater. A powerful tsunami forced people to flee to the roofs of the control tower in a flooded airport. So looks like the whole first floor is underwater there, and all the people are up on top of that building. Planning for earthquakes. Even though we can't predict earthquakes, we can prepare for them. Many seismologists help make information available to people so they can plan for and respond to earthquakes. This is especially important near the coast area. Once the shaking goes on for more than 30 seconds, Dr. C says, it's pretty simple. You have to run away from the ocean and run up a hill. You have about 15 or 20 minutes to reach higher ground. How cities are built also affects how many people survive an earthquake. Cities in many countries have special building laws. Buildings must be strong and flexible. That way they won't collapse during an earthquake. In some countries, however, buildings are often poorly built. The 2010 Haiti earthquake, for example, killed between 46,000 and 316,000 people. Unlike the earthquake in Japan, many of those people were killed by collapsing buildings and falling debris. However, earthquakes don't just destroy, they also create. They help make the mountains, coasts, and other landscapes we see around us. Dr. C explains, this is worth remembering as we learn how to predict and survive earthquakes in the future. What should we do? Now, we don't have any earthquakes here in Wisconsin that are notable, but if you lived in California someday, you might want to know what to do. If you are indoors, drop to the ground and crawl under a sturdy piece of furniture until the shaking stops. So if you're at school, it'd be your desk. If you're at home, maybe you have a big kitchen table you could crawl underneath. Stay away from glass, windows, outside doors and walls, and anything that could fall, such as a hanging light or a fan. Stay in bed if you're there when the earthquake strikes. Protect your head with a pillow. Only move from the bed if there is a heavy light or fan above your bed. Use a doorway for shelter only if you know it is strongly supported. Stay inside until the shaking stops and it's safe to go outside. Do not use elevators. If you are outdoors, move away from buildings, streets, and utility wires. Avoid any space where there is falling debris such as glass. Once in the open, stay there until the shaking stops. Alright guys, that was our reading story for this week, all about earthquakes. Expository writing, lots and lots of facts. Make sure you remember about the headings. The headings always help us if we want to go back and reread certain sections to find out more information. You can use the headings to find it quicker. God bless your day.